All right, we're live on YouTube, and it looks like Facebook is up. There it is. Happy Wednesday, everybody! It is the last day of September. October 1st tomorrow
Crazy.
already. Absolutely crazy. And we're going to be seeing some big changes weather-wise. I'm going to let Morgan talk a little bit about that because she did the 11 today. I have not looked really at anything weather-wise today. This is putting all this together. So we'll do that little brief forecast discussion. Hope you guys are having a great day so far and a great week so far. Hope everything is going well. We've got an interesting topic today. We are talking about surface maps. One of the sections of this is going to be a little more advanced, just to forewarn everybody. So if you feel like you're lost at some point, that's okay. A reminder, you can give us some questions at the end of the segment, and we'll be happy to answer those for you. So this is day 3 of Storm Trek 8 University. Exciting stuff. Really exciting stuff. So I'll pull up
Really.
the website for you, Morgan, here really quick. And if you want to just kind of give us a brief weather synopsis, if you will. Hopefully this is all updated. I know we've had some issues with graphics going out on time, but it looks good.
So
Here we go.
there we go. Yeah, so obviously, I'm sure a lot of us are hearing, or if you've been outside, the wind. It is going to be a very windy, gusty afternoon. Gusts have been getting up to around 40 miles per hour in some of our hometowns. So hopefully, you have all the trash cans, all the lightweight things hunkered down or in the garage. I'm sure you don't want to be chasing down the road after it. Um, Temperatures this afternoon, take advantage of it because it is starting to get sunny. We had a couple of showers this morning. Not going to be tracking much in terms of rain at all this afternoon. We're actually going to see more sunshine. So high of 67 degrees, not too bad given there is wind. So you're probably still that light jacket. But if you're paying attention to the highs for the next couple of days, we're going below 60. So it is going to be chillier for the next couple of days. And note Friday morning, the low by Friday morning is looking like it's going to be in the mid to upper 30s. That is going to be our potential to see our first frost of the season. So be sure you're taking care of your plants as well that are going to be vulnerable to the potential frost. Then we go into a gloomy weekend. But I know a lot of people have said I hate and I like whenever fall comes around, I feel like we just hit summer all the way to cold fall and we never get those nice, 70-degree days that are nice, sunny, crisp fall days. Well, look at next week. We're going to get those. So just hang on a little bit longer. We'll get there.
Yeah, this weekend's certainly looking gloomy, cool. Good day to be stuck inside working.
For sure.
Very cool. Thank you, Morgan.
Yes.
We'll go ahead and we will kick things off here. We'll go through the agenda really quickly on what we're going to be talking about. So, we're going to do a little bit of review. We're going to talk about surface fronts first. We talked about those in a prior edition of this earlier this year, but we're going to review it for those of you that are new. So, we're going to be talking about surface maps today, what they tell us, how to read one, which might be the most challenging part. We'll see what happens when we get to that up here. I tried to keep it as easy as possible, so hopefully we can get through this. And then we're going to do an exercise where we're actually going to look for a front using all of these station plots from the weather observations on the ground. Of course, at the end, we're going to have plenty of time for your questions, whether you're on the main Facebook page or our individual Facebook page, Morgan and I's. You can ask your question on any one of those, and we're going to check all three once we get to the end. But I'll let Morgan go ahead and we'll kick things off with the review of the types of fronts.
Yeah, so if you joined us last week, you probably recognize a couple of these things, but if you're new, we want to give you a little bit of a review because these surface maps absolutely show us where these fronts are. So we have the 4 primary types of fronts, warm front, cold front, stationary front, and a dry line. And I think we start off with a warm front. Yes, so I'll just do this. Um, so warm front, obviously, it is the boundary where cold air is retreating, so it is leaving and it's being displaced or pushed by that warm air. So that's advancing into the region. We get this gradual slope. So whenever you see a warm front, it's kind of lifting very gradually that cold air and it's going to allow clouds to begin to condense, and we usually see a lot of that stratiform rain move through the area, or just like gloomy, cloudy days. We can get thunderstorms with warm fronts, but we usually get those really long stretches of just gloomy weather for the day. And did you know the half circles point in the direction that the front is moving? So it's pointing towards the area it's moving in.
And I get a lot of people that ask that, too, especially the younger kids. They're like, why are the half circles on the top versus the bottom? And that's all about showing the direction in which it's moving. If you were south of the equator, those half circles would be on the bottom because everything is flipped when you get to the southern part of the globe, if you will. So cool little factoid there. So Morgan's got warm front. We'll take the cold front, and that is a boundary between two air masses where the cold air is advancing and it's lifting up that warm air, that very warm, unstable air. And you see that being depicted in the graphic here, the direction of the front moving from left to right, and you're getting that warm air lifted up through the front to produce showers and thunderstorms. Like warm fronts, it can also produce some severe weather, depending on the setup. You see a lot of line segments of storms along cold fronts. In fact, if you remember our derecho that happened in August, that was along a cold front that was moving through. So you can get a lot of interesting weather around there. There's what it looks like. It's that blue line with the triangles protruding out. Of course, also like the warm front, indicating which direction the front is moving. And typically that's going to be from west to east, or it's going to be from northwest to southeast, north to south in this part of the globe.
And then we have a stationary front, which is a boundary separating warm air from cool air, but it doesn't move much, meaning the cold air or the warm air, they can't really overtake each other. So we just kind of get this stalled boundary. And when this happens, it is providing lift for cloud cover, but they come in waves. So when we do see a stationary front, we kind of just see waves of rainfall kind of flush through, which we just had a situation off to our north. Wisconsin was just getting quite a few showers. I think this was just last week. And stationary boundaries are usually responsible for heavy rain events, and that is because they are stalled there so they don't move, providing that lift. So we just kind of constantly get those pulses of rainfall, which obviously adds up and can lead to rainfall, flash flooding, and that's what we usually see along a stationary front.
Yep. And if you remember last week, we talked about the Ring of Fire. Now there's a stationary boundary associated with that. We get those repeated storm complexes. The dry line, this is something we don't see very often around here. We might see it once or twice a year, but it's not very common. But this is a boundary that separates dry and moist air masses. So you've got dry air moving in and that moist air being lifted up over that dry air. So it's a very unique situation. You can still have warm air on both sides of the dry line, the difference being how much moisture is in that warm air. And this is something that we don't see again really often around here. You really see this if you're down in Oklahoma and Kansas. That's where you're closer to that downsloping effect off the mountain range sitting off to your west. And that's what creates these dry lines. They don't really age well as they go further east. They tend to lose a lot of their characteristics when they make it to our region here. So this is something more common out west, but it's also a chaser's dream because typically dry lines have some very photogenic supercells along them that include tornadoes that are very picturesque. So if you know a storm chaser, that is why they love the areas of Oklahoma and Kansas. It's much easier for them to see the features of these storms and get more dramatic photos when they're along the dry line. And here's an example of that. The Weather Channel putting together this really nice graphic where you've got the really warm, moist air to the east of the boundary. To the west, it's actually warmer. It's hot. You could have temperatures in the upper 90s, but the humidity and the dew point could be in the 40s and 30s. It's a big, drastic change. And just like a front, it's going to scoop all that up. And with a dry line, you add in a little bit more spin to the atmosphere, and that tends to produce a little bit more in terms of the tornado threat.
Yes, so now diving into surface maps after that little review, what do these things tell us? It's basically a quick overview, a quick snapshot of the entire United States, and it's giving us and showing us where are those fronts located. And it also tells us where areas of low pressure are and areas of high pressure. And a lot of information is told on a single snapshot of these. So there's a quick overview. um, I believe, Andrew, is this from today?
Yeah, this from this morning.
Okay, this is from this morning. So we have a area of low pressure off to our north and our northeast. A large cold front that actually swung through brought us those colder temperatures. Now we have another one that just swung through today, likely the culprit of bringing in some of those higher winds as well. And then we also have a couple of high pressure systems, obviously down the southwest where they're usually dry, and then right now just off the coast of Alabama and Mississippi.
And as Morgan pointed out, notice with high pressure, it's really quiet. There's no clouds, there's no rain, no storms. All of that's associated with the cold front and the areas of low pressure. So it's easy to tell where these areas of different pressure are typically, even if you're just looking at a radar and satellite map like you have here, based on the weather. So here's a couple of characteristics as we pull some of these out. So you've got a cold front that plowed through earlier today, like Morgan mentioned, dropping our temperatures and picking up the wind that we're hearing outside. Typically, you see rain and storms associated with it. We had a little bit of rain this morning. Noticed some wet pavement as I woke up. You also have the cold front winds will be turning from the southwest to the northwest. That's a typo. Forgive that. I forgot to fix that. But if you look at the wind arrows in ahead of the front, yeah, we're turning from southwest. So you see it's going from Texas to Arkansas to southern Illinois. But behind the front, you see those arrows are pointed in a totally different direction coming from the northwest. So from Canada, from the Dakotas, Minnesota, where it's much cooler. Notice the areas of low pressure too. They've got rain and storms associated with them. So it's not just the cold front, but the actual low itself providing some of that lifting motion that can drive some shower and storm activity.
All right. So, how are these surface maps made? Well, many surface maps are generated by computers automatically using data collected from weather stations. We talked about weather stations just a little bit, but during high impact weather like a tornado outbreak or hurricane, surface maps are often drawn by hand because it gives us a better idea exactly what's happening right now. Andrew has done it. I have done it. We have hand analyzed many maps in school. And just doing that hand analyzing, your brain is working with you. You're kind of seeing what's going on rather than getting that picture. So yeah, we got to do a lot of art basically in school, and a lot of meteorologists out there still do these hand analysis.
Yeah, it's still a popular thing. And I remember when I had to bring the colored pencils to class, Morgan, you probably remember the same thing where you're getting about a dozen maps and it's like, okay, you got to go through and plot where the fronts are, plot the different temperature contours where we're going from like 50 to 40 to 30 to 20 in terms of degrees. So there's a lot that you can do with these surface maps. And we're going to take a look at those coming up. And we're actually going to try and draw our own front to just looking at the service map. But yeah, this is a big thing still. We may have computers, but we like doing the hand analysis, especially for us during severe weather events. There are just so many small details that we can see with a hand drawn a surface map as opposed to something that was generated by a computer. Very, very helpful. So we're going to dive into the surface maps and how to read one. Brace yourselves. You may want to fasten your seatbelt. We're going to take this a little slower to get through this because this next section may seem a bit confusing. It's okay if you get lost because we're going to try and go through this one thing at a time. So we're going to go ahead and kick things off and look at a station plot. Here we go, Morgan.
It is It's a lot. It's a lot of information in just one single snapshot. But what you're looking at, all these little dots that you see, that's a different station model. And there's a lot of information that can be seen, and we will dive into that in just a second. But you can just also see a general movement of the map as well, kind of going with like the lines as well, which I think are those pressure
Yeah.
lines of equal pressure. Um, I was just double checking. So yeah, that's looking at pressure lines, and you can kind of see just like the flow of the map, how the front kind of goes along with that little dip that you can see in those lines. That's really how we can find where fronts are. But then when it comes to some other fronts, you got to really dive into what is the station model saying in that area? What is the temperature reading? Is there special weather going on? All that's good stuff.
Yeah, Morgan, I'm glad you brought up the dip or the kink in those pressure lines. I wasn't even thinking about that when I put this together, but you are right. You can often use the middle of that kink to determine where fronts are if you only have a pressure map and you have nothing else. So if you notice where we have the kink at here, there's one there, and it just keeps going and going and going. That's where our front is. And notice that lines up really nicely with kind of where the computer is generating it. It may be a little bit further south compared to where the computer thinks it is. But generally speaking, where you have that kink in the pressure bars, that's where you're going to have your front at coming in through there. So I'm going to erase that. And as she said, yeah, look at all the numbers. I don't know about you, more, but when I first had to do this, my eyes were just all over the place because you literally have to look at every little station plot and kind of put it in an inventory in your mind so that you can start drawing these lines. I mean, I feel like my eyes were like scrambled eggs as I was looking at this.
Yes, when my professor slapped down a black and white image and it was just looked like a mess, I was like, I don't really know how I'm going to do this, but we're going to dive in.
Yep, it takes a lot of concentration, a lot of staring at it for many minutes at a time. But once you do a few, you really get the hang of it, and it can be quite an enjoyable process. So we're going to start decoding the map and what all these little plots of numbers and arrows and lines mean. So here we go. We're diving in. So each weather station, current observation and weather is plotted on that map. That's what we were looking at. We were looking at things like temperature, wind direction, wind speed, pressure, dew point. There's a ton, obviously, because we have a whole bunch of weather stations all over the country, which is great. The more weather stations we have, the more data we have, and the more reliable our forecast models are because they're ingesting more data. That's why there's so many. So each airport and observation station and weather station has this kind of output to it. This is what's on that map, but plotted thousands of times. So you see a dot in the middle. What that represents is your sky cover. So for this one, the dot is full. That means the sky is overcast or cloudy. It will give you the pressure trend, which is rising or falling. In this case, for rising, because it's a positive number. It will give you the pressure in millibars, the wind speed. Each one of those lines represents 10 knots. A half line represents 5 knots. The wind direction, so this is the way the wind is coming from. In this case, it would be the northeast. The temperature is 76 in Fahrenheit. The dew point also 55 in Fahrenheit. And the current weather, I believe 2 dots is moderate
Drizzle,
rain, or it might just be rain.
moderate rain.
I'm
Yeah,
gonna say moderate rain.
light rain. I think it goes up to 4 dots.
Yeah, depending on the severity of the rains. But this is one example of what we had to memorize. We had to memorize what the current weather conditions were. So the thunderstorm was the little thing with the curved arrow, and you had to know what fog was, and mist, and drizzle, and snow. So there was a lot of memorization to this, but boy, is it helpful when you have to decode those surface maps.
There's a closer look at one, and this is of today, a current shot of today. And those little codes that you're seeing everywhere, each one has a code. We're looking at the arrows pointing to KMLI, which is Moline, that is out at the airport. So for the temperature reading there, you can see top left corner in the red, that is 61 degrees. The bottom left, that is reading the dew point, that is 51 degrees. And then the wind direction is coming from the northwest. As you can see, the arrow is, you kind of picture the little circle as the arrowhead of wherever that line is pointing from. So it's coming in from the northwest. That one line at the end of it, that's reading that it's 10 knots, which is roughly 8 miles per hour. 10?
Hmm. Yep.
Around that. And then half filled circle means partly cloudy, which, yes, that is where we're at.
Perfect. Yeah. And you may notice we will never ever show this on the air, ever, because it's too confusing. What we do on air is we break each one of these down piece by piece. So temperature is always on its separate map, dew point's always on a separate map, wind is always on a separate map. And you may ask, well, why don't we just do that as meteorologists when we're doing this hand surface analysis? Well, I don't know about you, but I don't want to repeat the same process 5 or 6 times just looking at different variables. I would rather have all of my eggs in one basket, if you will, my temperature, my dew point, my sky cover, my wind, all of it on one map. So I have to do this hand analysis once. I know it's a lot of fun, but me personally, I'm all about efficiency and multitasking. I only want to do that once. So that's why we kind of keep it all together on these types of maps. So what can we conclude based on that plot that Morgan just decoded for us that we just went through? Well, the wind is from the northwest, so we probably had a cold front that moved through or is moving through now. So true. That just happened earlier today. The dew point, it's 51. If you follow us a lot on air, we talk about the dew point all the time. 51 is a low dew point. It's dry, fairly dry anyway. And that's also typical behind a cold front. So now we get to have a little fun and see if we can figure out where this front is. So here's our station map.
So,
Go ahead.
yes, here's our station map. And really, the biggest key thing is paying attention when you're trying to find a cold front specifically. We try to pay attention to the wind direction as well as what the temperature is doing and the weather.
Yes. And I might be able to. Oh, I can. Perfect. I can zoom this in a little bit so you guys can get a better view of what's going on. So maybe we can kind of stop or start rather in the upper left-hand corner, maybe make our way down a little bit here. So you notice the winds, much of Iowa coming in from the northwest, because again, think of your arrowhead as that wind is driving the arrowhead in its proper direction. Let's look at the temperatures. Low 60s. There's some mid 60s mixed in there. Look at the dew point. Wow. Upper 30s, low 40s. Let's go a little bit further south. Winds are more out of the southwest.
Mm-hmm.
Temperatures well into the 70s. Dew points a little higher, 50s, 40s. Go a little east.
See a
Kind
little
of the
bit of
same
rain in
story.
the
Oh,
Lafayette
sorry. What'd you say,
region of
Morgan?
I said I see a little bit of rain in the Lafayette region of Indiana.
Oh, yep.
Just, yep, right there. We see 2 dots on that weather station.
You're right. Yep. KLAF. Wonder could be causing that.
Another 2 dot weather station in Fort Wayne.
Yep. Notice the temperatures, dew point,
And
well into the.
also notice how the sky, there's a lot of cloud cover right now in along the state line of Illinois and Indiana. But if you were looking at the west, there's a lot of clear skies, which is also an indicator that a cold front has passed through.
There's some more clues. Sunshine in
Sunshine.
Iowa. We've got sunshine kind of coming through here. That's a terrible sun.
I was like, what are you drawing at first?
So let's go back over our clues because we got an extra minute here. So Morgan pointed out clouds in this region here where you see these solid dots. Look at the wind, northwest. Over here, southwest. We've got some rain. So something's cooking in there. something exists. Something is moving through there. And this was taken this morning, by the way. So this is not something from the past. This is ongoing, fairly recently today. So I'm going to erase all of that. Do we have any guesses? I don't see any guesses so far. I think people are sorting it out in their mind. Let's zoom in one last time. Good northwest breeze. Very strong. We've got almost 10, 20, 25 knots. That's getting close to probably 30 miles an hour, if not a little bit higher than that.
Which verifies that's exactly what we're seeing.
Hmm. Tell you what, I'd rather have those 70s in Missouri's versus what we have right now.
Me too. Me too. That would be beautiful.
All right, we'll zoom back out. Here we go. Drum roll. Bam.
There it is.
There's our cold front. Actually
So
making
yeah, we have a lot
some
of
progress.
yes, a lot of cloud cover, a couple of rain showers popping ahead of that cold front, and everything behind the cold front is drier as well as getting clearer and windier for today because we have that
Hmm.
extreme temperature contrast going on.
Yeah, we do. Very strong pressure gradient due to the temperature contrast, as Morgan mentioned out. So it's gonna be a little breezy out there. But the folks ahead of the front, still a little bit more moisture. Really, a lot more moisture to the south part of this front, which is no surprise. The further south you go, that's where you're going to see the better moisture this time of year. So there it is. There's your lower dew points behind the front. Cooler temperatures, winds from the northwest. Good job, everybody. We're proud. It is time for your questions and comments.
Questions. Okay.
We'll pull up our streams.
Come on. All right. I got none on my personal.
Okay. I've got Angel saying hey. Jeffrey's checking in from Riverdale, Iowa. Linda's saying no, too close to getting snow. I don't even want to talk about that
Yeah, we don't need to mention that word.
word. I see Seth Ashland checking in.
Hi, Seth.
How do you like them graphics and the music? Let us know. Should be no surprise. It's the same for every Tegna station. So
That is true.
Linda says, good for the fall days. David's saying good afternoon. Morgan and Andrew, Dave from Galesburg, little sunny and windy. Don't see anything else. There. Okay. And nothing on my page. I'm clear.
We have Dale saying, Andrew Morgan, I'm definitely in your fan club.
Oh,
We
hey.
got a fan.
I like that. We like our fan club. Who's the president?
He also said, if I watch all of your series and pick up a few things, are you going to give me an amateur meteorologist certificate?
What a great idea. Oh my gosh.
We might have an exam at the end of this series, so
Yes,
stay tuned. Keep
that is a
listening. We could have.
fantastic idea. We'll have to get with our creative services team and see what they can whip up for a fancy certificate that we
Yes.
can hand out.
Give you a reward for keeping up with us.
Yes. I think we're all caught up. I don't see anything more.
Oh,
Looks good. And we're right on time. We're at 1:30 on the dot.
perfect.
So we're going to be back next week. Um, we are going to be talking about air pressure. That's next on the list for next week. And there was an experiment with that, but me and my brain that does not latch on to that kind of information. I don't remember what the experiment was. Do you remember what it was?
I did the experiment. It was you put the balloon in the water bottle and you try to blow it up, showing the displacement of air and how pressure works in and out. I don't know if I
Oh,
can whip it
cool.
up again. I'll make it work. You just need a balloon and a bottle.
Nice. So just like a water bottle.
Yes, I was using a Gatorade bottle because it was easier to work with or easier to see.
Okay. So next week, guys, you have an assignment. You have to bring a water bottle and you need to find a balloon because Morgan's got a really cool air pressure experiment that we can do. I think I have a balloon around here somewhere. I know I got plenty of water bottles, so that's not going to be an issue. But we'll look forward to doing that next week. That'll be day 4, same time, right here, 1 o'clock on the WQED Facebook page, Morgan and I's Facebook page, and of course you can stream this at YouTube as well. Morgan and I, we did our first Zoom virtual classroom visit yesterday, and I got to tell you, it was a blast.
It was so fun. Loved it.
We probably the highlight of the whole thing was not only seeing the kids because we certainly miss getting into the classroom and seeing everybody, but at some point during the Zoom call, it turned into a free for all in terms of pet show and tell. So we had Morgan's cat, my dog, all the kids were turning their cameras onto their dogs and their cats, and oh my gosh, I could have done that the rest of the afternoon.
Oh, it was so funny. So, yes, we are super interested in doing classroom Zoom visits or Skype or whatever. We can make it work. Um, yeah, reach out to us. Let us know. We'll be happy to make something work.
Yes, absolutely. We've already got one in the pipeline. We're working on some scheduling details, but let us know. Throw us some dates. If it doesn't work, we'll find another date. But we'd both be happy to visit your classroom and talk about whatever topic you would like. And it's suitable for all ages. We can do kindergarten all the way up through high school. There's certainly material that's adaptable for every age. So don't be shy thinking, this is too much for your class. We can keep it simple or we can go more advanced. Whatever you guys want, we will certainly tailor it to whatever you need. So all you have to do for that, just contact Morgan, myself, email, Facebook, any of those communication methods work. We can get them something scheduled out for you to help your classroom and see your kids. So we look forward to seeing some more of those emails come in.
Lastly, I see Madison Connor commenting on your
Hey,
stream.
Madison.
We miss you.
We do. We miss you so much. I know Cooper misses you. All right, guys, we're gonna hop off. Enjoy the rest of your Wednesday. Don't blow away. I gotta take Cooper for his walk next. Might have to weight him down a little bit because it is a little breezy, and he's got a lot of hair, so he could go airborne quite easily, even though he does that on his own all the time because he jumps like crazy. What's that?
Cubs game. It's on right now.
Ah,
I'm about to put
yes.
that.
So we had the White Sox last night, right?
Yep, White Sox last night. They won.
Uh-oh. Who's the Cubs playing today?
The Marlins.
Oh, that's nothing. That's nothing. Unless they're losing dramatically right now.
They're not losing. They just started. So.
Oh, good, good. Okay. We got this, Cubs fans. We can do this. We can do this. Well, if you're going to go watch the game, enjoy. If you need to get back to work, yeah, it's hump day. It's almost Friday. That's what I'm going to be doing after my lunch break here.
Oh yeah.
Um, Morgan, we'll see you this weekend. I'll see you this weekend. And then we hope to see you right back here, 1 o'clock next Wednesday for air pressure, water bottle, balloon, and an appropriate balloon.
Adult supervision.
Yes. We need some safety goggles too. We might even need a waiver. I have to check with legal. We, I don't know about you, but I don't have the budget to get sued.
True. Nope. Not.
Yeah,
Or you can just watch us do it.
that's true too. Yes. If you feel uncomfortable, you can just watch it. All right, guys, enjoy the rest of your Wednesday. We'll see you this weekend, if not next week.